hello, 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 hello. Hello, 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 hello. Hello, 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 hello. It's working, 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 working. Okay, yeah. Sorry for some noise in the beginning as I was testing the system. This is quite yeah, technical kind of a system that I'm using for the first time, and I have heard from my seniors that this system has often goes up and down. Yeah, I can't do much with that. And yesterday when I was using this system, it was apparently doing the live stream, but later on I found out that yeah, it was not really the case. So as I promised yesterday that I will do the recording again and upload. So this session is for that to fulfill that promise. So continuing with from where we left in the first lecture. In the first lecture, we talked about we had a course overview and then we talked about some basics introduction about the Java programming language. We looked at how a simple Java program looks like, what are the statements, and what how you can write a Java program and compile and execute it using either a command line or using maybe Eclipse as an IDE. We looked at what the identifiers are and the keywords, and yeah, we also looked at what are the different data types and reference types and the variables, and how the types are converted from one type to another. And we also looked at the various operators and how these operators are evaluated. Then we also talked about arrays, what the arrays are and how we can use them in our program. And the next thing that was planned was in the first lecture was the control statements, but we could not make in the first lecture. So I will continue from control statements. As the name indicates, these statements are used to control the flow of the execution of our program. And so by default, we know that a Java program executes sequentially, beginning from the first statement in your main method, which is the entry point of a Java program. So, but in some cases, there are cases when we want to change the order of the execution depending on the condition. So, for example, we say that if in normal life we have, we have tasks that depends on some conditions. So, for example, taking the example of an examination system where we say that the student will be evaluated for being to pass or fail to pass a course. We have a certain condition that a student should pass the assignments, should pass the examination, and also the examination should be passed with certain numbers. And if it doesn't pass, it should be it has to redo the assignment, retake the course. And so so in order to achieve this kind of things in a programming language, so we also have this control statement structures, and so we will look at this. So we have basically three kinds of control statements in Java. The first group is selection statements, which contains if, else, and switch statements, and then we have iterative statements, while, do, while, and for. These iterative statements are used when you want to perform a task several number of times. So if you want to repeat a thing again and again. So for example, if we want to print something 5 number of times, so instead of writing this system.out.println 5 number of times, we can use maybe these iterative statements to do this again and again. There are also some operations where we use the same kind of instructions are executed again and again. So and then we have these other statements which include break and continue. We will look at them in a short while now. The first thing is the first statement if else. It has two parts, as you can see here, if and the else part. And in the if part, we have this Boolean expression. The Boolean expression means an expression which should return to a Boolean value, either a true or false. So we can only use in this expression here, we cannot use anything other than an expression that returns to a value true or false. So, and then we specify within the if, this is an if block, where we specify the instruction that we want to execute if the condition is returns to a true, because we know that Boolean expression will either return to a true or a false. So if the condition is true, the if block should be executed. Otherwise, if we want, the else part will be executed. If the condition is false, the else part will be executed. To look at an example, for example, here we have an integer marks variable, and which we use to find out if student is able to pass or fail or not a course. And so to do that, we put a condition: if marks greater than or equal to 40, print out pass, else the print should be a fail. So whenever you will execute this statement, it will check this condition within the if, and if the condition is depending on the evaluation of the condition, it will execute either this if part or the else part. So only one of these parts will be executed, not both. And there are also some conditions. There are also some cases when we have multiple conditions, and to specify the multiple conditions, we use this nested if-else statement. The nested if-else statement is where we have an if statement put within another if statement. So if, for example, if you want to find out not just whether a student has been able to pass, but we also want to find out if student the grade of that students. So and to find out that, we have to define multiple conditions. So for example, if the student has a marks more than or equal to 90, then we know that the grade should be A. Otherwise, the grade, if the student has marks more than 80, then it should have a grade B. Marks more than 70 should have a grade C, and so on. So for such conditions, we can use nested if-else. So the nested if-else means that there are another if statement within another if statement or another else statements. So to give you an example, it will be more, I think, better to understand using an example of an if-else statement. So here we have a class with the name of if-else demo, and then we have inside the main method we have this marks variable, and we have the statements to find out. So when this program will execute, it will check this condition. So for example, in this case, the marks are 95. So when we go to this statement, it will check the marks 95 is greater than or equal to 40. So condition is true, so it will print out pass. Otherwise, it would have, so this condition will not be executed because the condition is true. So this is that's why we call it like a selection statement. So if we don't have specified this condition, both these statements will have been executed. And then it goes to this to the next statement, which is a call to another method with the name of print grade, and we pass the marks variable as an input argument. And then from there it jumps to the method print grade, and here we find out the grade of a student depending on the marks. So it's this nested if else, the if else statements, these are quite common in other programming languages. So if you have already learned Java or if some other programming language such as C or C++, I think you will be familiar with this construct. So there is nothing complicated. So, for example, if you run this program now, so because it goes here, it finds out, it checks the marks and print pass, and then it calls the print grade methods. And since the marks 95, the first condition is true, 95 is greater than or equal to 90, so it assigns the grade A. And since when one condition is true, the other condition will have been ignored, and it will go back, jump to this system.out.println statement. But on the other hand, if I put the marks like something like 30, so in this case, when it comes to this condition, it checks marks 30 greater than or equal to 40. The condition is false. So the if part will not be executed, but the else part will get a chance. So it will print fail, and then it calls this method. And here, when it goes to this part here, it checks whether the marks are greater than or equal to 90. Since within the marks the value is 30, so it checks the condition is false. So it goes. So the condition becomes false. So this if part doesn't get executed. So it goes to the next else part. Within the else part, we have another condition. This condition is also false. So it goes to another else part where we have another condition. So this is also like 30 more than or equal to 70 is false. So this condition is again false. So it will keep on until the next condition, last condition, where it checks again 30 greater than or equal to 40. This is also like false. So in that case, it goes to the last else part where there is no more condition. So it goes just to the else part and assign the grade is equal to F. So now if you run this program, so it will just print the fail from this part, and then it prints the grade, which is in this case is the grade is F. So that's how this if else statement works in Java. If you have I don't think that there is anything complicated here, but if you have questions, you can put on the forum. Then we have an equivalent to the nested if else. We have another selection statement with the name of switch statement. This statement also uses begins with the syntax is that it starts with the switch, the keyword switch, and then you specify an expression. But the difference between if else and the switch statement is that in the if statements you can only use Boolean expression to evaluate, but in the switch you can use any type of expression, which is integer type of expression or character or string, and to define the different parts, which parts should be executed. The switch statement allows user to define the number of cases over here, and the case should have the values associated with the expression. So if you are using an integer expression, then the case should be defined using integer type of values, and if you are using a string or character type expression, then the case values should be defined based on the string or character values. And so when the switch statement is executed, the Java compiler checks, evaluates this expression, and matches this expression, the value of this expression, according to the case values. And if none of the case values matches with the expression value, then it executes the last part, which is the default, the default case. So the default case gets executed when none of the upper cases become matched with the switch expressions. So and to separate one case from another case, we have this break statement here. If you don't put the break statement, the switch statement will keep on executing until it finds a break statement. So for example, just to give you an example here, we have this switch statements, and for to control this switch statement, we use a day, which is an integer type expression, and we have defined the cases using integer values 1, 2, 3, 4, and so on. And what does this case switch statement do? it uses an day expression, and then it assigns the day, I mean the string values to the variable of type string, t string, either Monday, Tuesday. So based on the value that matches to the case expression. So for example, in this case, we have the value of day is equal to 1. So it goes and checks with the different cases defined. So the first, in this case, the value matches with the first case statement. And so the day string will get the value of Monday. And then since we have a break statement, so the switch, so the break statement will put the control out of the switch statements. So but if the value of day, for example, is 7, so then it will evaluate the cases. So the case 1 doesn't match with the value 7, so it will jump to the next case. 2 doesn't match, so keep on, and then it goes to the case 7, and here the value matches. So and then it will assign the value of Sunday to the day string, and then it breaks. But if you specify the day value is equal to 0 or 8 or 9, that doesn't match any of these case statements over here, then in that case the default statement will get executed. So that's that's also one way to control the flow of your statements within the Java program. And the next we have the iterative statements, and these statements, as the name indicates, if you want to do a task again and again, so these are to execute a statement several number of times. These statements are used. For example, if we look at here, so this is what we have. I mean, for example, just to give you an example here, we have this class iterations, and then we have this method with the name of main. And if we want to, what we want to achieve is that we want to, the system is not really, it's stuck once again. That's really unfortunate. I don't know what's wrong with these systems over here. Yeah, it's really unfortunate, but something that I cannot control. Let's see if I can use the whiteboard. Yeah, at least this part is working. So, so for example, within your main method, so if you want to print out something like, if you want to print ln like hello statements, and if you want to do it like 5 number of times, the one way is that you need to write these statements 5 number of times. So, and that's one way. Or if you want to like print numbers from 1 to 100, one way is that you print out by one, writing one by one. Another way to do is that you use these iterative statements. And these iterative statements we have, as I told you before, that we have 3 kinds of iterative statements. But since this system is not working, so I have to restart this one. So I will see. Yeah, let me see if I don't know what's. So sorry for that, but you have to wait. So hold on, please. I'm just restarting the system because it was stuck on somehow. I don't know. So I'm now restarting the system, so you have to wait a while. Yeah, it's now restarting. At least I got some signals here now, but it will take, I think, 1 or 2 minutes. Okay. Mm-hmm. Okay, yeah, I think it's, so we were, let me see where we was. We were talking about, yeah, iterative statements. So here we come back. Okay, yeah. And yeah, as I told you that the syntax of the while statement is that it starts with the while keyword, and then we specify the Boolean expression that is used to control the number of times the loop should be executed. And then we specify the statements that should be executed within the body of the while loop. And similar to the while loop, we have another type of a loop which is called do while loop. The difference between while and do while is, as you can see here, in the while loop we have the expression at the beginning, but in the do while loop we have an expression at the end. So as you may guess, the difference will be that since we check the expression at the beginning of the while loop, so if the condition becomes false at the beginning, the while loop will never execute. But the do while loop, it will execute at least once, and then it will check the expression, and if then the expression becomes false, it will not execute. We will soon look at an example to see how these loops work on. So just to remind you that the difference between while and do while is that while loop, the do while loop will always execute at least one. I could execute more than one time as well, but the while loop there is no guarantee that it will execute, it could execute either 0 times or maybe depending on the condition. So if the condition becomes false at the beginning, the while loop may not get a chance to execute. And so here we have an example of a while and do while loop. So in the while loop we have the value of which is based on the value of integer I. So we initialize I is equal to 0 and j is equal to 1, and then we check I less than equal to j. So first time I is not equal to j, so 0 not equal to j, yeah, that's true, condition is true, so it will increment the value of I. So the value of I will become 1, the j value of j is decremented, which becomes 5. So it goes again to the condition and then checks 1 not equal to 5, the condition is true, so it will execute, and the value of I will become plus become 2, j minus become 4. So it will go back again and check the condition. So the value of I is 2 and 4, which is not equal. So it will increment the value of I, and the value of I will become 3. The value of j will become minus. So from 4 it will jump to 3. So then both variables now will have value of 3. So it will go to the while loop and yeah, checks the value, the condition. So the 3 not equal to 3, which is false because 3 is equal to 3. So the loop will will come to an end, and it will go out of the loop, and then it will print the statements, and which are printing the value of I and j. So the output of the I and j after these loops will be both pointing to 3. On the other hand, we have a do while loop where we have yeah, the syntax is that we put the do keyword and then the body of the loop and the while at the end. And here we in this loop we ask the user to enter a number from the keyboard, and for that we use this utility class, scanner class, and and the syntax is here, scanner.in. We create an in type object from on, and we call the constructor passing out the system.in. System is the Java language, is the class in the Java lang. So and then we yeah, and in the end of this loop, so we are within that loop we ask the user to enter a number, and then we read a number calling this int.next integer, and we add those number to a sum, and in the condition we check while n not is equal to 0. So this means this loop will keep on executing until user doesn't doesn't enter a value of 0. And in that case, we don't know the number of times when the user will yeah. So this loop could execute maybe yeah 5 times, 6 times, 7 times, or 8 times, depending on when the user entered the value of 0. So and the next statement we have in the iterative part statements is the part of the statement is the for statements. The for statement is similar to it is in its yeah, in its working it is quite similar to the while loop, but its syntax looks a bit different. We have within the for statement begins with the for keyword, and then we have the first part of this statement is the initialization, where that part we can use to initialize the variable that we used to control the execution of the loop. For example, here integer n is equal to 1, and then we have a condition where we check that is used to control the number of times this for loop to control the execution of the for loop. If you don't have a condition, the for loop will keep on executing maybe forever. And then we have an update, that part that we use to update the value that we use to control the execution of a loop. So for example, here we have a for loop, and and the condition is for that loop is that when the value is of n is less than equal to 5, and then we have n plus, and we print the value tick 1. So first time the value of n is 1, it checks the condition 1 less than equal to 5, which is true, so it print out these values, and then it increments the value of n from 1 to 1 times n plus, so n becomes 2. It checks again, the 2 is less than 5, true, it prints the value and then goes 3, 4, 5. When the value of n becomes 5, it checks the condition. Condition is still 5 is equal to 5 true, and then it prints the value, and then it increments the value of n, which becomes 6. And when it becomes 6, it checks the condition, and then the condition becomes false, so it comes out of the loop. And then we have also this break and continue statements. The break and continue statements, these statements are used if you want to interrupt the execution of iterative statements. You can use, of course, you can use these statements in other parts of your program, but normally we use them in the to control to interrupt the execution of our while, do while, or a for loop. Break statement, wherever the Java compiler finds a break statement, it in your iterative statements, it terminates the execution. And they continue forever and takes the control out of the loop. But the continue statement, it skips the current execution. It doesn't terminate, but it skips the current iteration, and the statements that are followed after that continue statements will be skipped, and it will transfer the control back to the start of the iterative statement. So that's the basic difference between break and continue. So this brings us to the end of the first lecture, and here you can find some suggested chapters from the complete reference book. Although you can use any other textbook that covers these topics that we have studied in this first lecture. But just to give you an idea, you can read out these chapters, and also you can look at these different tutorials by Java, Oracle. These are the Java tutorials, so you can find out. It's good to read out for further information. And then there was some information about the lecture, the second lecture, which was planned for today. So now I will move on to this second lecture. And this second lecture, this lecture is about object-oriented concepts using Java. So we will first look at some basic terminology that is used in the object-oriented programming, and we'll also have a brief overview of what an object-oriented programming is, and then we will talk about some key concepts, that abstraction, encapsulation, inheritance, and polymorphism. So beginning with what an object-oriented programming is, it's basically a programming paradigm. It's a way of to write computer programs, and the basic idea is in the object-oriented program we use the concept of objects to model and to model the problems, to visualize the problems, and to solve those problems in terms of by defining the objects. And the idea of object-oriented system is taken from the daily life. If you see in our daily life, we find a number of different objects, and the human life, the different functions that we perform, these are performed by there are different objects that interact together. For example, in an office you find different objects, so in different employees, and and also the home appliances and the office machines, and the employees of the office are using those machines to perform their function. And similarly, if you go to some industry, you also find different industrial objects. So for example, robots and other machines that which are the objects, and these objects interact with each other to perform their operations. So the idea of object-oriented programming is taken from the base of the object-oriented. The central concept in the object-oriented programming is an object. And what an object is, it's in a simply we can say an object is any tangible or physical thing, but it doesn't not necessarily to be a physical thing. An object since we often in programming when we are solving problems, we often find conceptual concepts or objects. So, but the fundamental to the idea of object is that each object has certain states or attributes which distinguish an attribute or an object from other objects, and also each object will have a behavior, certain behavior, and the behavior simply you can understand behavior as different operations or methods which an object can perform for its tasks. So, for example, if we consider a person as an object, so a human or a man as an object. So, the states are the attributes of a man, or like every person has a name, has an age, maybe he has some address, telephone number, email, height, weight. All these things are the attributes or the fields of a person object. Similarly, if we talk about a car object, color of the car, the brand of the car, the manufacturer, the year, and the engine, the type of the engine. These are different attributes of a class of a car object. And then the different behaviors are like the car can accelerate, it can run, it can stop, and it can turn, it can, these are the different operations are the the behaviors and the behavior of car object. And similarly, if we talk about a person object, the behavior of a person objects include a person can speak, can walk, can run, can sleep. So these are different behaviors of a person. And then behind every object, we have the idea of a class. Every object is an instance of a class. What a class is a blueprint or prototype that specifies the behaviors or the attributes of an object. So what operations an object can perform and what attributes an object may have, all these are defined in a specification named as a class. So for example, if we have a class person, in Java you can specify the class. We can see that later on, that how we can define or specify a class in Java. But to have a general example, if we see the example of a person, you have to specify these attributes within a class definition. And similarly, if you have a time class, if you want to specify the attributes and behavior for a time object, so you need to define a class time with these attributes and different behaviors. So this is a UML diagram for this is how we can visualize. UML is a modeling language used to design the software systems. So a class in a UML is often modeled as using this box notation, where we at the top we have this the name of the class, and then we define the attributes of the class, and at the bottom we have the behaviors or different attributes. So for example, set name, set height. This was how we can define a class in a UML. But if we talk about how we can implement or declare or define a class in Java, so this is the general syntax. So every class definition starts with the keyword class, and before that you can have access modifiers, which is an optional part. All in this definition, all those items which are defined, which are enclosed in square brackets, for example, this access modifier and static keywords, these are optional. These are optional parts of specification, so these can be skipped. But the other parts are mandatory. So, for example, you must need to define to declare or define a class. You need to start with the class keyword using a class keyword, and then followed by then you need to every class will have a class name, and the general convention is that the class name starts with a capital letter. So, and then you have a variable's name. The variables are these are the attributes of a class. So and you can define any number of attributes for a class, and every attribute will have some type. It could be a primitive type or it might be a reference type. And the reference types are usually defined using the class and the interfaces. We will talk about interfaces later on. And then we have the constructors. These are the constructor is a block of code which gets executed. It's a special block of code which gets executed when we create an object of a class, and you can create any number of objects for a class. So, for example, to give you to understand the relationship between a class and an object is like, for example, human is a class, and every human being that lives in this world is an object of class human. And similarly, if we talk about there are other types of classes as well. For example, bird is a class. Every bird can fly, and every bird has color or something like that. So these are the general specifications of a class. But then, when we see different birds, we find the different birds that we find in the world. They are the different objects or the instances of the class. So and the constructor method is a block of code which gets executed whenever the new object of a class is created. And a special thing for the constructor method is that it must have the same name as the name of the class. You cannot use any other name. So, for example, if your class name is car, then the constructor name must be car. And if your class name is person, then the constructor name must be person. And then you can have a parameter list. These are the parameter list, or the input values that you pass to the constructor methods. And then at the end we have the various methods, we have a method definitions. The methods that, are used to define the behavior or the operations that are performed by a class. So, and you can use any number of the methods to define the behaviors. And the syntax for that is that it also begins with the access modifier and statics. We will talk about later on what the access modifier and static are. And every method may have a type, which is the return type. This is used to specify the value which is returned as a result of the operations of a method. And if a method doesn't return any value, then the type should be specified as void. Otherwise, the type should be specified based on the type of the value which is returned as a result of the behavior or a method. For example, if a method returns a value of type string, then the type should be string. Otherwise, if it returns the value of long or double, the type should be specified as a long or double. And then we have the parameter list, same like as the parameter list for the constructor. Okay, and moving forward, so here we have an example of a person class. We have in the beginning we use the access specifier public. We will talk about soon. I think in the next few slides what the public means, and and then we have the fields at the beginning. A general convention is that we specify the fields at the beginning, the attributes at the beginning of a class, and then we specify the constructor, and at the end we specify the method. So, for example, in this case, for a person class definition, we have specified 3 attributes: name, height, and weight. And we have a 4th attribute, which is a static type of attribute, int person counter. I will shortly describe what the difference between static and non-static attributes. So the attributes which are defined using keyword static, they are known as static attributes, are also known as class level attributes, and the attributes which are defined without using the static keyword, they are known as instance or object attributes. And then we have the constructor. As I told you, this is used the constructor part is executed when the object is of that class is executed, and then we have the method. So if to look at how this class definition looks like in a Java, how we define this as a Java code, we just look at an example of this. So, for example, I already, just to save some time, I have created this. I have defined this class over here. So we have this class person. It's defined within the package lecture2. You can use any. The package, as I told, introduced in the first lecture, the packages are used to organize your classes. So for example, here this class, I am using this class for lecture2. So I have created a package with the name of lecture2 and put all the classes that I use as an example for this lecture in this package. And so we begin with this class keyword, and this public is the access specifiers. And then we have a private also access specifier. So there are four different types of access specifier in Java: public, private, protected. And if you don't specify any specifier here, then it goes to be the Java it's we call this access specifier as a default or no modifier specified. So you can, as I told you, that this access specifier part in the class definition is optional. You can skip or you can use it. The difference between these, there is the level. Based on the access specifier, the classes will have a limited visibility. It could be if you declare a class to be public, anyone outside the package can use this class. But if you can access and use this class, but if you define this class without using the keyword public, then only the classes that are within that package can access this class. So we will see what are the difference between the different access specifiers. And then we declare attributes, and then we have the constructor methods. The first constructor method, we have 3 input parameters. You can have more than one constructors, or you can even also omit the constructors. If you don't specify any constructor, then the Java default constructor is used. But normally we use the constructor to perform the operation that we want to be performed at the time of object creation. For example, we want to initialize the attributes of the person object when the object is created. So for that, we have defined this first constructor, which takes 3 parameters and assign these parameters to the arguments, to the attributes. So for example, the first attribute is a string type, so we have defined the parameters as of type string, and then another is int, and another one is for the height and width. And also, if you want to have these objects, to create an object without specifying this value, initializing these values, so we can have another constructor, which is an empty constructor, and it doesn't specify any value, so the parameters are left empty. So, and if you see here in this constructor, we are using other than initialization, we are incrementing this static variable person counter. We are using this as person counter variable, which is attribute, which is the objective of this is to compute the number of objects. Whenever we want to keep track that how many objects or instances of class have been created. So what we do, that since we know that an object, when we create an object, this method will be invoked. So whenever an object will be created, we increment the person counter variable. So if you create 3 person objects, so 3 times one of these constructors will be executed, and each time this will be executed, so the value of the person counter will be incremented. So in the beginning it will be 0, but then whenever we create an object, the value will get incremented. And then we have the attributes after these constructor methods. So we have this get name method. We often use, a general convention in a Java language is that the attributes are defined with using the private keyword, the access specifier. And what does private means? Private means only this class can access these that can view and these attributes. No one from the outside of the class can view. This is just to keep the attributes safe. We declare the attributes or data members as a private. So, but to provide the access to these variables, we use public methods. getter and setter methods. The getter methods are used to get the values, and the setter methods are used to set the values of these attributes. So for example, here we have the methods with the name of get name, and then at the bottom we have the set name, which has been used. So these are the getter methods, and then we have the setter methods. So difference between the getter and setter is the getter methods, I mean, they are used to get the values of the attributes, and the set methods are used to the setter methods are used to set the values. For example, if we have a set name, so and it takes an input parameter of type string, and it assigns that value to the attribute name. And then we have a set height and set weight, which takes the integer type variables as an input argument parameters, and assign these values to the height and weight. And then we have another, if you print person method, it prints the information about the person class object. And if you see how we can use the print, the main method we have, and the main method demonstrates how we can create objects of a class, and how can we use and manipulate the information of the person of an object attributes. So to create an object of a class, at first you can create an object of a class using the keyword new. So for example, here, if I want to create an object of type person, so I can use new person, and one way is that I create the person without passing any input parameters. So this will create an object, and without any initialization value, but we will have no reference. We will have no access to the object created. To get the access to that object, we need to assign it a reference variable. So that reference variable should be, we need to assign the address or the reference of that variable to a variable of type, reference type of the same class. So for example, in this case, the object we are creating is of type person, so we declare a reference variable of type person, and we need to assign the identifier for that reference variable. So for example, we want to say a person with the name of Alpha or something like Johan, and assign. So in this case, the new person will create an object, and the address or the reference to that the object, newly created object, will be assigned to the Johan. So, and then if you want to change any information, you can use you can call these set methods. For example, Johan set name here, and then we can pass the value Johan as an input parameter. Okay. So and I already have created two other objects of person type, Trump, new person, and I have already passed the information to this. And then I have created the Putin object without any information, but we can use set name and set height. And then we can print the information of these, and then we can also print the how many number of total number of persons initiated using this get person counter. So so in this class we have created 3 objects. So when we run this program, the number of objects should be 3. The total number of person initiated 3, and here it displays the information of person Trump and Putin, because we call the print information on these objects. So this is how you can create an objects of a class and use the objects of that class. And so this is, I think, if you have used and some other object-oriented language, so you will be familiar with these concepts. But if you have a question, you can just post your question on Moodle, and I will come back to you. Then moving forward, here are the 4 different access specifiers. And as I told you before, the access specifiers these are the keywords provided by the Java language to control the access to the different parts of a class, to the class members. And there are 2 types of class members. One are the member methods, and the member attributes. So we have 4 types of modifiers: private, and no modifier. No modifier means if you don't specify any modifier, and protected and public. And if you declare a method or attribute as a private, so it means only that class, the class itself can view or access that method. No one other than that class can access. But if you define a class without specifying the other three, public, protected, or private, so then that attribute could be accessible by the class itself and other classes which have been declared in the same package. So for example, if you have three classes in a package, then the three classes will be able to access that member method or attribute, but no one else will be able to access that member method or attribute. And then we have a protected keyword, and a protected keyword is used if you want to a member method to give an access to the subclass of a class. So in that case, we use a protected keyword. So the protected keyword members will have the class itself can access it, and the other classes within that package can access it, and also the subclass can access it. And in case if you want to put no restrictions and you want to make a method or attribute available or accessible by all other classes, then we use the keyword public. And as I told you in the beginning, that according to the standard practice in Java is that you should keep your attributes or data as a private, and you should provide the access to that data through the public methods. So that's the access modifiers. And then here is some information about a method. What a method is? It's basically a collection of statements, and we also call them member methods. And syntax of a method declaration, we already have looked at it. The first part is access specifiers, and then we have a static keywords, and then we have return type, a method name, and parameters that are passed as an input value, and statements. So for example, here we have some examples of a method definitions. We have public set name methods, and as I told you, if a method doesn't return any value, so the return type will be void, and then the name and the input parameters. But if you want a method to return something, for example, there you have a method which takes two values and sums those values and return the sum of those values as a result. So in this case, since it's returning to the sum of two integer values, which will be the integer value itself, will be also an integer value, so the return type is int. And there is another method which takes two number and finds which number is minimum is of the two numbers, are the lowest of the two numbers. And to call a method, we have the syntax is that to call a method, you need to have you can call a methods using the object reference, and after that you put the dot operator and then the method name and the input parameters that match with the method definition. So there are two types of methods. We have a static method, and we also have non-static methods. The difference between static and non-static methods we will talk about soon. But if it's like the static methods are also known as class methods, and the non-static methods are known as instance methods. And to invoke an instance method, you need a reference to that instance, putin.setName. And if it's a class method, you can call it with the name of that class. So person.get person counter, for example. And next, it's some information about the constructor. And as I told you, constructor is a special kind of a method or a block of code which is invoked when an object of a class is created, and we use it to initialize or to perform the operations that we need to perform when an object has been created. Some fundamental features of important things about constructor, that a constructor will have no return type, but it doesn't mean that constructor doesn't return. In the constructor definition, we don't specify the type, but constructor method always returns the reference to the class, to the object of a class which has been created. And also the name of the constructor should be the same as the class name. to which the constructor method belongs. So for example, if the class name is person, it should be person. And the class may have 0 or more constructors. So if you don't define a constructor, so there will be a default constructor used to create an objects of that class. Okay, we already have seen how the objects are created, so I'm just skipping this information over here. Then we have some information over here about static and our class versus non-static instance members. The static keyword, as we've seen in a class person, is used to declare fields or methods that belong to the class. So sometimes, I mean, in general, we want, when we create objects, there is some information that we want, that every object want to keep separate, that every object would like to have its own name, its own class, its own name and email and address. But there could be some information which could be common among all the objects. For example, if we are talking about a student class, every student has its own name and email and address. But maybe the university name could be common, or the institute name may be shared among the objects. So this kind of information which is shared among the objects could be declared as a static member attribute or member method. And the differences are, some characteristics are that static members are accessed using the class reference. So for example, if you want to access a variable, you can specify person.counter and the person the method name. But if you want to access the instance members, you need the instance of that class. So for example, to access the height and the method set name, which are non-static, we need the reference or the instance of that class. So first we need to create an instance using the person trump is equal to new person, for example, and then we can use that instance to access those variables, the non-static variables. And other than that, a special thing about static members is that a static method can only access the other static members. It doesn't have direct access to the non-static method, so you cannot invoke a non-static method from a static method. But on the other hand, a non-static method will have access to both static and non-static members. And we cannot use the keywords this and the super within a static method, but we can use this or super within the non-static. And the difference between what this and super is that this is a special keyword which is used to refer to the objects of the same class in which you are using the code. So you can use, if you want to invoke a method of this class, so you can use, instead of using the instance of the same class, you can use this dot, the method name or the variable name. And if you want to invoke or access the members of the super class or the parent class of the current class, then you can use the super keyword. So you can instead, where you use the reference, you can put the super keyword and you can invoke the methods or access the methods of the super class. So I hope this will be clear, but if you have questions, as I said before, that just post your questions on Moodle and I will get back to you. And then the Java comes up with the number of class library, the number of useful classes have been defined. The idea of these library classes is that to provide users or the programmers with the useful classes that are commonly used, so that instead of writing, asking the users to write those classes, the Java provides with the utility classes and some fundamental classes to speed up. The idea is to speed up the programming process and to speed up the language, the quality of the programs. And there are quite many classes provided by the Java, the library classes. These classes are also known as the application programming, the interface or the Java API. And these classes are organized within the different packages. For example, some of the popular packages, commonly used packages are java.lang, java.util, java.io, The java.lang, it provides the fundamental the Java language classes, which includes, for example, system class, string class, and object class. You can look at the Java class library, I think, using, if you go to this, it's this link. No, it's, I don't know, just wait on. Yeah. So it's opening up. It's also known as Java documentation. So if you go on to the current version, as I told you before, is JDK 10. If we go here, you can find the API documentation, and if you go there, if you click on this, here you can find out the different modules. One of the module is another level of it's a top level to organize the different packages. For example, if we go to the java.base module, here you can find the packages java.lang, and if you click on this, you can find some information, read out some information about what this java.lang package is, and you can find the different classes defined within this package. For example, here we go, the object class. It's so one of the we will talk about soon about the object class. It's a parent class of all the classes. So all the classes that you declare are defined in the Java are the subclasses of this object class. So it's defined the basic methods for a class, and then you also have in this package you will have this system and string class. So, and you can look at what the class is and what are the different methods of these classes are. So some of the important classes to look at and to play with includes java.util.arrays, ArrayList, random, and scanner, and string, and math, and file class. So you just go into this. For example, if you want to find out more about the ArrayList class, you go there and you just type. You can search also for a specific class. For example, if you write down here ArrayList, so within this types we get this java.ArrayList. So you can read about ArrayList class and the different methods of this class. So to get in more information about that, so I strongly recommend that you should visit the documentation of the Java API and read about these useful packages and library classes. And to give you an overview of what an ArrayList is, we will use this. I have prepared an example for you guys. If you look at this class over here, ArrayList is basically it's a library class which provides you an implementation of an array-based list. The difference between array, we can also use, as I told you, to create a list, you can also define an array. But the difference between array and array list is that the problem with the arrays is that you need to specify the size of an array when you want when you want to use. And for example, and when the number of items in an array increases or becomes more than the size of that array, you have to recreate the array. So for example, if you have defined a list, an array with the size of 100, but after some times, if the number of elements in that array becomes more than 100, then you have to resize that array or create another array. But in case of array list, if the size will grow, it resizes dynamically. So you don't need to specify the size of the array list. You just, when you create it, whenever you keep on, when you add the elements in an array list, it dynamically resizes or adjusts its size based on the number of elements stored in it. And also another thing is that in array we can only store the values of a specific type, but in array list you can store any values of any data type. But and also it's also you can also restrict the type of values that can be stored in an array list. For example, if you want to store if you want to create a book list, and you know that the book list, a list of books, and the books, the value that you want to store in that list will be of type string. So you can you can specify this after the array list by specifying the type within the diamond operators. But if you remove this thing over here, array list. So for example, I mean, what is the difference here now? So now I have specified that this book list is of type string. So it means it can only contain the values of type string. So if I try to add a value using some other, no, it's a books list. So the array list provides you with the library methods. So if you want to add a value in this list, we can use the add method. And if I put a value of integer type, so you will see that the Java will complain here now. It says that the method add Java compilers creates the syntax error, the compile time error, and it says that the method add int string in the type is not applicable for the arguments int. So because we have specified the type of the array list to be a string, so we cannot add the values of any other types. But if I remove this, then you can see that it doesn't complain anything. But it's generally it's not a good idea to mix up the values of different data types. So if it's not needed, it's a better practice is that you always keep, whenever you use use an array list class, try to specify the type of values that you want to store in that list. And then this array list provides you with some useful methods. For example, this add method is used to add values within that in that list. And then if you want to check, it provides you with the is empty. If you want to check whether the list is empty or not, so you can call this is empty method. And if you want to get an index of some specific value, you can use the index of method. If you want to know the size of the list, you can call the size, which will return you the size value. And if you want to see whether the list contains a specific value, you can call on this method dot contains. And also you can get some specific value at specific index. So this, you can just look at this class and try to execute and see. So how you can how can you use this array list class? So coming back to the lectures, we have already talked about the Java library classes, API, and the next thing that I would like to talk about in this lecture is the interfaces. Interfaces, these are used to separate. Basically these are quite similar to classes, but there are some differences. Both interfaces and classes are used to create reference types. But we used why we use interfaces is that we want interfaces are used to separate what a class do from how it does. So it means that if you want to specify specification of a class from its implementation, then we can specify that the operations of a class in an interface. So and then to provide the implementation or the actual functionality of that those operations, we force on our classes to implement the different interfaces. To understand a use of interface, why we use the word interface is because a class usually interact or interface with the outside world through its public methods. As I told you that the class has two kinds of attributes. It has a member, it has a member data, which are also known as attributes, and then it has a member methods. But the member data or the attributes are kept private, and the access to those attributes is provided through the public methods. So the methods are through which a class interface with the outside world. And the public methods this means that the public methods form the interface of a class. So, and in simple, you can understand an interface as a collection of public methods. But this is not really, I mean, the interface, I mean, why we need interface is that sometimes, you know, when we are working as a practice, we work in several teams, and we want to divide our tasks between our several members, but we want to specify, for example, the general behavior. I mean, the general before splitting the tasks, we want to agree on between the but when we are doing this thing, we before dividing the task between the team, we make sure that the code from different teams or the team members follow some standard rules. So, and for this we used to agree on a contract. Such contract are defined in the form of an interface. So, for example, if we are if we need to define a list of type integers, and we want to split this functionality, we want to delegate this functionality to our team member. So we define an interface for this interlist, and in this interlist we tell our team member that we need that the class should have a method that takes a value of integer type n, and that it adds that value to the integer list. So we don't need to return to get any value as a return. And then that class should have a method which takes a value with the name of get, and it takes a value, integer type value, and it returns the value which has been specified at the position that is passed as an input value. And then that class should have a method with the name of contains, and it takes an integer value, and it returns either true or false based on whether the value is contained in that class or not. So basically, in its simple form, we can say that an interface is a collection of methods, abstract methods, and these abstract methods are the methods which have been defined without the body. So there is no body defined. So, and we want to separate this. We want to simplify this, and we want to delegate this to different team members. So and we want to tell him that okay, the class that you should implement should follow this contract and should follow the signatures of the methods which are defined in the according to this signature. So, and then the other class member can use this interface definition to implement the code. And when you implement, when you make a class, and you we will see that how a class can implement an interface. So the Java provides us with the keywords implements. And if you force a class, when you make a class to implement an integer list, then Java compiler forces the class to provide the implementation for all the methods that are defined in that interface. So for example, here we have only defined the signatures or the general structure of a methods. So there is no implementation of those methods has been provided. And but then to provide the implementation of those methods, we need to have another class that implements those methods. And the idea of interfaces is also very important because when we want to, if you have a situation where you have where the implementation can vary from one class to another class, but the general interface remains the same. So for example, we have a class animal, and we have an interface animal, and we know that every animal will have some sound. but this the sound of the animals varies from one animal to another animal. So, for example, a cat will have a different sound, and cow will have a different sound, and maybe dog have a different sound. So, in that case, we define an interface animal, and then we require the different. Then we create various classes, and ask those classes to implement the interface. And when we make a class to implement an interface, we put a restriction that it should provide in implementation. So the class will have its own implementation. Cat class will have its own implementation of the sound method, and the cow class will have its own implementation of the sound method, where it says like system.out.print mew, and horse has its own sound. So in a situation where you have a different, where you know that this is how we separate, this is how we separate what a class does from how it does. So how it does has been defined here, and what a class does, it has been defined here in the interface definitions. And also we use the interface definitions to specify the general structure the general behavior of methods, the general the signatures of a method, and then the implementation details are left over in the class. So, for example, here we have an int list, and here we have defined the abstract methods. The abstract methods are the methods which have been defined without any body, and the implementation of these. But then to use these methods, we have to have another class which implements these methods, and this class must have to provide the implementation of all those methods which are defined in this int class. So if you see that int list interface has 4 methods: add, get, and contains, and size, and then the implementation is here. And if we remove any of these methods, for example, if we comment this size method, so the Java compiler will complain, because, and if you read out the method, it says that the type int list must implement the inherited abstract method int list dot size. So it's like the relationship between interface and a class is that a class enforces a contract on a class, that an interface defines a contract and forces the class to fulfill that contract, and to use the interface definition and to provide the implementation, you need to define a class together with this implements keywords, and after the implements keyword, you can specify the name of the interface that you want this class to provide. And a class can implement maybe can implement 0 or 1 or more than 1 interfaces. So it depends on the requirements of your program. So in this case, this class is implementing only 1 interface, but it could have implementation for more than 1 interfaces as well. So, and then moving forward, so this is the same information that I have talked about now. So this is the implementation of the interface, and then we have the list main method which demonstrates the use of this the interface definition. So just look at this. So it is basically creating an integer list and then using the methods to add elements and the size, and how this size could be used. So so now we have looked at some basic concepts of the Java object-oriented things, and the remaining, there are 4 fundamental concepts, which are the abstraction, encapsulation, inheritance, and polymorphism. And understanding to this concept is quite important to understand, to design a sound object-oriented systems. What are these concepts? These are basically some conceptual concepts. So the abstraction, the basic idea of abstraction is that you don't need to care about all the details, but you can only focus on the specific details and capture or specify the system that are relevant to your current perspectives. So it means that when you are designing a system, and everything about that you get from the customers or the user is maybe not really important. Some of the things will maybe only relevant for those employees or the users, but they are not really important for implementation from a software system point of view. So you can ignore those details, and you can focus only on the details that are relevant in the beginning. And also you can have the multiple levels of abstraction. So for example, in the beginning you can have an abstraction at a high level, but then you can define when you go further and when you know more about the system, you can add more details about the system. So for example, to understand an abstraction, a very classic example is that a class, a cat may have can be seen from a different perspectives, and cat may have a different abstraction. So for example, we as an ordinary owner of a cat, as a pet owner of a cat, we see a cat as a domestic animal, and we see that it can jump, and it can it can eat, and it can drink milk. So, but if we look at a cat from a doctor perspective, so a doctor maybe look at the cat from the medical point of view and medical perspective. So it looks like whether it has a healthy lungs and kidneys and stomach and all the internal bones, and so it will have a different abstraction of. So the different users may have a different abstraction. So depending on your system, so you don't need to put I mean everything. You don't need to take everything in account. You can only take the things which are important, and you can ignore other things. So this is one of the fundamental way to mitigate complexity and things, simplify the things that are both in the real world and also in the software development. And the Java supports abstraction through the abstract classes and interfaces. So we have already learned about the interfaces. So for example, when you define an interface, you only specify the general signatures or the general the method, and you don't specify the details how the method implements those things. You only specify what methods should be there, but you don't specify how these methods should be implemented. And similarly, an abstract class may also have such kind of methods, which are known as also the abstract methods. So, and how can we define an abstract class? The difference between abstract class definition and the normal non-abstract class definition is that you put abstract keyword before the class keyword. So when you put the abstract keyword before the class keyword, so the class becomes an abstract class. And the abstract class generally contain an abstract methods, and there may be one or more abstract methods. And the idea of using the abstract classes is that, for example, you want to have, it's quite similar to the idea of the interfaces, that we know that we want to ignore the details that are not relevant in the beginning. So for example, we want to implement a system that calculates the salaries of employees. So, and for that purpose, we create a class employee, and we know that every employee will have some salary and some payment per hour based on its working. So, but we know that there will be different types of employees. Some of the employees may be regular employees, and then some employees may be contractual employees, and those employees may get different salaries depending on their the different their nature of their contract and the nature of their employment type. So so we don't know. I mean, at the employee at the first in the beginning, we may not know how the salary will be calculated. So in this case, we can specify on the abstract level that an employee will get a salary, but how it will get the salary and what will be the salary of an employee will be, we have no idea. So, and to specify this, we can declare abstract methods, And the difference between an interface and object class is that in the interface you generally have abstract methods only, but in an abstract class you can have both abstract and non-abstract methods. So the difference between abstract and non-abstract method is the non-abstract methods are our normal methods which have a body, but the abstract methods have no body. They only have the signatures of the methods, the return type, the name, and the arguments. But in before Java, this was true before Java 8, but now in Java, after Java 8, and in current version of Java 10, Java interfaces may also have default methods. So these are the methods that are defined with the default keywords, and static methods as well, but we don't go into the details here. We simply use interfaces that are defined with the abstract methods. And now, if we want to see how these abstract classes can be used. So, for example, we have an employee class, which we know that it will have some payment pay per hours, and then it will have a get salary. And then we can have classes for a contract employee. And in the contract employee, we say that this and the abstract classes are used by asking other classes to extend and provide the definition of those methods which were kept abstract. And so one class, if then we have a class contract employee which extends the class employee, and here we have the working hours, and here we have the salary method, which is so and also it's important that when a class extends an abstract class, that class is required to provide the definition of all the abstract methods in its the class which it is extending. So, for example, in the employee class has a method get salary, abstract method. So this contract employee class must need to have the definition of this get salary method. If we remove this definition of this method, and save this one, so you will see that the Java system will complain about it, and it says that you must need to add the unimplemented abstract method get salary. So these are some the rules defined by the Java. And then and in the get salary methods for the permanent employees, we know that the salary is computed based on its working hours, and the working hours for the contract employees are defined when the object of that contract employee is created. But then on the other hand, we have another class with the name of regular employee, and in the regular employee, we know that it has a fixed number of working hours defined in the class, and so we don't need to specify the number of hours when the regular employee is created. So in that case, we can have the working hours specified as a fix. And then if we go into the demo of this employee class, we see that here we have contract employee CE1, and we create an object of that, and we can say that this employee has a working hours of 6, but and also we can create another employee of type contract, and let's say we call it contract employee 2, and we can, because the contract employee may have a different context, and so the contract employee gets 6 hours a day, and then we have another contract employee which gets only 4 hours a day. So, and then if we print out the information, and then we have a regular employee, and the regular employees for the number of hours are fixed. So we don't. So when we call the get salary method, so it will execute the set salary method based on the number of hours and the salary. So for example, I just want to add the salary for the statement for this newly created contract employee object, and also the salary of that object. So now if I execute this one, so if we look at see that Johan is a contract employee who works with monthly salary of this, because he has a working hours of 6 hours, and then we have a working hours of 4 hours, and then we have a working hours of 8 hours fixed, and we can also change the name of this to distinguish it. X, Y, Z, something. Okay, so that's how the object classes are used, and so what the objective of the interface the object classes are. So yeah, and so this is what I have already told you. And the important thing about the object classes are that you cannot create instances of the object classes. So what it means that we cannot. I mean, if you look at here, we have defined the reference type of employee, but we cannot create an object of a reference class. Because why we cannot create an object of an abstract class is because it contains a methods, object methods, which have no definition defined in. So and using the method without invoking a methods or creating a Java system puts restrictions on creating objects of classes with the object methods. And then moving forward, so this is just the examples code from the classes that we have already looked on. So I just move on. And then we have Java interfaces versus object classes. So both the concept of interfaces and object classes, they are quite related to each other, but there are some fundamental difference. Both support abstraction. The similarities are that you can use both interfaces and also the object classes to achieve the abstractions. So because you can use both to define object methods, and both may contain a mix of both abstract and non-abstract methods. And you cannot instantiate or create objects of neither the interface or not the object classes. But then these are the similarities, but then there are some differences between the two as well. Some of the fundamental differences are that with the interface, in the interface, all fields are the attributes that you define are by default public, and with the public access, and they are at the instance level. And final means that you cannot change the value there of these variables once the values have been defined. And then with the object classes, we can declare fields that are not static and final, and define public, protected, and private. So the object classes provide you with more choices to declare the attributes. And another difference is a class can implement any number of interfaces. So we will talk about what this means. But on the other hand, a class can extend only one abstract class. So you cannot extend more than one classes. You cannot make a class to extend more than one classes, abstract classes, but a class can implement more than one interfaces. So this means that if you want to, so sometimes you want to have a class to have a definition for the multiple the operation defined in multiple interfaces. And then another difference is that an interface can extend any number of interfaces. So we will see what this is related to the inheritance, and the next thing, the inheritance is the next thing that we are going to talk about. And on the other hand, an abstract or non-abstract class may implement any number of interfaces. So these are some differences between interfaces and object classes. So the next thing, the next important concept is encapsulation, and also known as information hiding. The basic idea of this principle is that show only those details to the outside world which are necessary for the outside world, and hide all other details. So, and in the Java, the encapsulation, it means that you don't need to show everything to the outside world. You keep all the details hidden, and you provide only because otherwise, if you show all the complexities and the details, it might be difficult for the outside world to understand and find out the information. And and Java supports this encapsulation through using these access specifiers, public, private, and protected. And to hide the information, the Java uses the private access specifier, and the member methods. The member fields are the attributes are defined private. And also, if you want to hide some methods from the outside world, you can also declare the methods with the keyword private. So sometimes the classes have internal methods that they use for their internal computations, and they don't want to expose those methods to the outside world. So these methods can also be defined as a private methods. And to show the details to the outside world, you can have the Java provides you with the public access specifiers, and the methods usually the getter and setter methods are defined as the public methods to allow the access and manipulate the private member variables, so which have been kept private. So this is how you can achieve encapsulation or information hiding in Java. And the next thing is inheritance. Inheritance is another important feature of object orientation, and this feature enables new objects to take on and extend the properties of existing objects. So for example, if you have defined some properties within one object, and then you want to extend those properties, and you also want to keep the existing objects, the properties defined in the existing objects as a separate. So you can delegate the features of or the properties of the existing objects to the new objects, and this is done through the mechanism called inheritance. And this mechanism allows a child or a subclass to acquire or inherent features from the data members and the member methods from one or more parent or superclasses. So the idea of inheritance is from maybe the human beings. So as a human beings or the other animals, we inherit features from our parents. So for example, often the children have their appearance similar to their parents. They are quite similar in their shape and hair and color to their parents, either the mom or the dad. And we also inherit some other properties. For example, we inherit depending on the different cultures. So a child may inherit some property like a house or home or a car or some other businesses from their parents, and a child may also extend those features. So everything within the child is not the same. For example, if a person is a good in one sports, it is quite often the case that the children may be good in that sports as well through inheriting through the genes. And but then a child may also add new features to itself, to its personality. So he may supersede his parents. So he can improve the characteristics or the features that he owns from his parents and adds new features. So this is the same. That how the inheritance works in case of object-oriented programming. And how does the inheritance works, and how can you make a class, how we can derive a class from another class. The syntax is that we use extends keywords. So if we want a class to inherit features or properties from another class, like superclass, and the class from which we inherit is known as a super or a base superclass or the parent class, and we specify the name of that class after the extends keywords. So for example, here we have a class person which has the common attributes defined as a name and age and gender, and then we have the attributes eat and walk. But then we have a different subclasses of a person. Maybe student is one class, and teacher is another class, and doctor is another class. And we all know that these all three different classes, they have the same features as every that are defined on that every person has. For example, since every student, every teacher, and a doctor at first is also a person, also a human being. So every student will have a name, every teacher will have a name, and every doctor will have a name. So instead of defining these features separately in three different classes, we can define the common features in the parent class, and then we can ask the subclasses to inherit from the parent class. So, and this is the Java UML notation to how this inheritance works. And then a common term used and the relationship for the relationship between parent and child class is a relationship. And what does the is a relationship means? It means that since if we read about here, every student is a person, teacher is a person, and also doctor is a person. So every object of subclass is also an object of a parent class. So every student object is also a person object. So this is so based on this analogy or relationship between parent and child classes, so we call the relationship between them as an is a relationship. And also inheritance also implies another important principle is a generalization and specialization principle. What does this mean? This means that the parent classes generally specify a general structure, while the subclasses specialize that structure according to their own needs and according to their own behavior. So for example, a person has a general behavior, eat and walk, but student has a specialized behavior. For example, he studies, he takes exams, and a teacher has a special behavior or the methods. He teaches and takes exam, and then the doctor has special behaviors and attributes that no other person have. So the general behaviors are normally defined in a superclass, and the specializations, the specialized behavior are specified in a subclasses. Some of the important facts about inheritance in Java is that a subclass inherits all the public and protected members of its parents. We already seen this when we talk about access modifiers, and but the private members are always kept private. They are not inherited. So it means that subclass will have no access to the private members of its parent classes. And and then subclass inherits all the other than inheriting all the public and protected members of its parents, subclass may declare new variables or the new methods according to its needs, and it's also may override. What does the override means? Override means that it can when a method overriding a method means when a parent and child class have a method with the same name. So in that case, a method is overridden by a subclass, and if the method is not defined in a parent class, in a subclass, so and then if the object of subclass calls a method which has been can use the methods of its parent class. So for example, if we have a method, if you look at this example, so if we have this method with the name of eat defined in the person class, so student object can, other than using its own behavior, study and health, the student object can also access or call the methods eat and walk. But if the student object defines its own eat and walk methods, then this method will be, we say that these methods are overridden by a subclass. And also it's important to know that all the classes that we define, they automatically become subclasses of java.lang.object. So the object class is a superclass of all the classes in Java, and we already talked about super and this keywords. So the super keyword is used to access the member of the parent class. So for example, super.getName, and this class is used to get the access to the methods of the current class within which you are calling the methods or the attribute using these keywords. And both these words, static and super and this keywords can be used anywhere in a class except in case of a static methods. Then we just look at some details about the object class. As we talked earlier, that all Java classes implicitly inherits from the system.object class. So it doesn't matter if you specify or not. In this case, we have two definitions of public class person, and so in one case we have a person class which extends from the object class, and in another case we have a person class without extends keywords. But in reality, both of these class definitions are same. So it doesn't matter if you specify the extends object or not, because the Java, when the Java compiler compiles this code, it automatically makes the class definition to be a subclass of the object class. And this means that all the methods of object class can be used by all types of objects. And some of the useful methods provided by the object class are the equals and get class and toString and clone methods. And the equal method is used to compare the objects the values of two objects, whether the values are equal or not. And and the get class method is used to get to find out to which class an object is a member of, or and the toString it returns the string representation of the data attributes of an object, and the clone method is used to create a new object with identical values, field values of an object. And here is some example of how you can use the methods of object class. So for example, we have, if just to give you an example here, we have here a class with the name of class number, and here we have the main method of this class, and then we have these methods with the name of overrided methods. So for now I just comment these methods, and if we now go back to the code here, the number class has one input parameter. It has just one member attribute of the private integer num, and then it has a constructor, and then it calls to the main method. And in the main method, we create an object of type number, and then we initialize it with the value 1, and then we print system.out.print x.true string. And those toString methods, if it is not defined by a class, then it will call the toString method of object class, the parent class, by default. And this toString returns the name of the class to which the object is, and it returns this string reference of that class to which an object is the member. And then we have this the x.get class.get name return the string consisting of the name of the class of which the object is the member, an instance. And then so if we run that class now, so we will see that what happens. .toString, it returns the name of the class to which it is a member, and then it returns the hexadecimal value equivalent to the value which is contained in this parameter. If you have not defined this method, overrided this method, it will return a string which will consisting of the name of the class of which the object is an instance, and then followed by an @sign, and then the unsigned hexadecimal representation of the hash code. So, but on the other hand, if now we have not overrided this method, but we can, I mean, this doesn't look a meaningful value. So to make it a meaningful value, we can have override the toString method. And what does we do when we override? To override a method, we used an annotation. And the Java provides with annotation. These annotations are special information. These are the meta information for the compiler, and it tells and all the annotation starts with the @sign. And this override annotation tells the Java compiler that we are going to override the methods with the name of toString. And in this method, we simply return a string and the value of the input parameters, the data attributes. So now, if you execute this method, this program, so when it goes to these statements, instead of calling the toString method from the object class, it calls the toString method which is overridden in this class itself. Okay, and similarly we can also call the other object methods such as .getName, .getClass. So .getClass returns the class of that the object and the name, and similarly we can use the equals methods as well. So that's how we can use the different methods defined in the object class. And then we also need to know the difference between equals method provided by the Java lang.object and the comparison operator. The difference between the two is that the object.equal method is used for value comparison to check whether both the variables have the same values or not. And on the other hand, the comparison operator double equal to is used for reference comparison to check whether both variables point to a same reference or to the same object or not. For example, here we have three different variables of type string s1 and string s2, s3. All the three variables contains a Jonas value, and the first two have the same information, but the third has in the uppercase. And then if we use the comparison operator, so because if s1 double equal to s3, the condition is false. Why? Because s1 and s3 are not the same references. They are not pointing to the same reference, but they are pointing to the two different variables. So that's why it returns false. And then if we compare s1 double equal to s2, even though both have the same values, s1 have the value Jonas, s2 has the value Jonas, but it returns false because the double equal to comparison operator doesn't check the values. Rather, it checks the reference if the two objects are if the two variables are pointing to the same reference or not, to the same objects or not. And when we say that if s not equal to s2, because the two are not pointing to the same value, so they have a different references, so this returns to a true value. And on the other hand, if you talk about s1 dot equals to s2, it will return true because both s1 and s2 have the same values. And if we talk about s1 dot equal s3, it will return false because s1 and s3 has different values. So, and and then there is some syntax about overriding. I already talked to you about how you can override a method. I mean, an overridden method means when a parent class and subclass has a method with the same name, and if you want the child class to redefine the method which has been defined in its parent class, you can do that using the override notation. And using override is not mandatory, but you can even override without providing this, but it provides information about the compiler, and the compiler checks at the compile time that you have overridden the method completely correctly or not. So you must have to provide the override annotation. If you don't provide, the compiler at the compile time will not check whether you have overridden it correctly or not. And then the last thing in today's lecture is polymorphism. It's also an important concept in object orientation, and the idea of polymorphism is to have one interface and multiple behaviors. So you define one interface, but you want to achieve multiple behaviors depending on the different depending on the different the objects and their behaviors. So for example, if we look at again the idea of polymorphism is achieved using the interfaces, and it can be easily understand if we look at an example. So for example, here you can see that we have an interface with the type animal, and then in this interface we have method sound. We already have seen this example when we were talking about the interfaces in Java. And then we have three classes: cat, cow, and horse. All three classes implements the animal interface. And when they implement the animal interface, it means that they need to provide the implementation for the sound methods, which is been defined in the animal interface. And then if we go back, we have another class which demonstrates the use of these classes and of the animals implementing the animal interface. So in this main method, we have an array of animals with the size 3. And on the first index of the animal array, we have an object of type kite, and on the second we have an object of type cow, and on the second index we have the object of type horse. So, and then we have a for loop, for each loop, which iterates on all the elements of the array of type animals, and then it calls the a.sound method. So, and from here, when we execute this program, if we go to the Java and to the Eclipse, sorry, and if we go to this class with the name of polymorphism, yeah, here it is. So, when we run this code, this a.sound will invoke three different methods depending on the type of the object that is pointed by the variable of type animal. So if we run this code now, at first when this loop execute, at the first position, at the first index, the object will be of type kite. So this statement will invoke the sound method which is defined in the class cat. And next time when we go to the loop executes and it will go to the next index. So the next object at the index animals 1 is of type cow. So the next time it calls the sound method in a class cow, and it prints the sound of moo, and then it goes again, and the next time the object pointed by the a is of type horse, so it calls the sound method defined in the class horse. So it means that the polymorphism it provides with the feature that allows a program to behave differently depending on the type of the object which has been stored in that method. So, for example, in object-oriented polymorphism refers to the language ability to process variable values, for example, in calls differently depending on their data type or class. And so for example, in this case, so the code is the same, the interface is the same, but the call to the methods is different. The behavior of the program is different, and and it depends on the type of the object, which is the runtime type of the object. So if the type of the object is of type cat, it calls the methods of the class client. If it's the type of the object is cow, it calls the method from the cow. So this is this kind of a feature which allows a program to have one interface and multiple behaviors is called polymorphism. And the word polymorphism is derived from the Greek word which means like multiple forms or the multiple behaviors. We have the Java supports two kinds of polymorphism. One is known as static polymorphism, and another one is known as dynamic polymorphism. Static polymorphism, the word static is often related with the compile time evaluation, and so it means this kind of polymorphism, or the target of a method is determined at a compile time, and it is achieved through a method overloading. And what is method overloading? Method overloading is when a class have multiple methods defined within the same class, they have and with the same name but different signatures. So, for example, a class may have a method with the name of draw, and which takes one integer value and as an input parameter, and the return type is void. And then it has another method with the same name but a different parameters. So when there are more than one methods defined in the same class with the same name but different input parameters or different signatures, so such methods are called as method overloaded methods. And the Java compiler at compile time determine which methods should be invoked by matching the parameters or the signatures to the methods invocation. And then we have a dynamic or a runtime polymorphism, and the dynamic or runtime polymorphism is resolved at runtime and is achieved through the method overriding. And method overriding means when you have multiple methods defined with the same names but in different classes in a superclass, and when a method defined in a superclass is overridden when a subclass redefines the method using the same name and signatures. So, and this could also be the method overriding could also be, or the dynamic polymorphism could also be achieved using either the parent and the subclass relationship or also through the interface definition. So, when you define a method in an interface, and when you make your different classes to implement that interface, and each implementation has its own implementation of the method, and then so that method is also overridden, and the method invocation and the Java at the runtime will determine which type of method, which method should be invoked or behavior should be invoked, what should be the behavior of the program, and that behavior will be determined through the runtime type of the object by which the method has been invoked. Okay, so so that's it, I think, and you can read about the concepts that we covered today in today's lecture. You can read more about these things in the chapter 6, 7, 8, and 9 in the book by Herbert Childress, the complete reference. You can use either the 9th or the 10th edition. And I have provided you with some links about some Java tutorials. You can find these tutorials on these links. And also go through the lecture slides, go through these chapters and these tutorials, and the lecture slide, the example codes that we use in these lectures to demonstrate these concepts I have already uploaded it to the Moodle. So you can play with those examples as well. And then the next in the and if you have a question, of course you can put your questions to the Moodle. And then in the next lecture we will talk about Java generics and collection frameworks. So it will be good if you can read about these topics before coming to the next lecture. Okay, so thank you very much, and see you in the next lecture.